Hi, everyone. Thanks for coming to Bridging the Divide, which is about the noble quest of bootstraps, sugar, and spectral pyramids, and primarily about all the mistakes I've made and how you can avoid doing them too. I thought I would start out framing the conversation with a quote from the great philosopher Trooper. If you don't like something about your language, change it. So a little bit of discussion about this talk, talks about this talk. My name is Brooklyn Zelenka. I'm XP'd basically everywhere on the internet. I'm the CEO and chief scientist at the Special Projects and Decentralized Engineering Company. We work primarily in blockchain, doing R&D. I'm an Elixir core dev, Ethereum core dev, too many E's. I've authored a bunch of standards. Main one these days being Fission Framework. And at a previous company, I'd worked on a language called Clarity, which I'm told IOHK has something similar to now called Marlowe. I work almost entirely in open source. I'm a programming language theory enthusiast. I founded the Vancouver Functional Programming Meetup and was previously an Elixir consultant and corporate trainer. And I've written a whole bunch of Witchcraft, Elixir libraries, including Witchcraft, LG, Quark, Exceptional. There's 6 or 7 of them. I also have stickers. If you're a sticker person, come find me at any time. I just got a whole bunch more printed and would love to give them out. So this talk is really a follow-up to one that I gave in New York about this time last year, called Love Potion number 9, which was about Elixir, where it sits in the ecosystem of all languages, and how we can extend it to do other things, right? To bring in other concepts. So for those who don't know, some of the libraries I mentioned before, because we're going to be talking about them as examples throughout this talk. Witchcraft is basically bringing Haskell idioms and essentially the standard library into Elixir. LG is bringing algebraic data types. Quark are all the classic combinators and currying and auto-currying into Elixir. And Exceptional is an exception handling library. So structure of this talk, we'll be talking quite a bit about philosophy, principles for library design, a toy example at the end, and it's also partly an experience report from writing these libraries. So why libraries? Why not talk about languages? Much ink has been spilt on language design, but much less about libraries and extending languages, right? They have slightly different constraints. The same principles apply, but you have to work within the constraints that somebody else has already set for you. And when you're bringing in a concept from a different area, you still need to make feel and work the same and be interoperable with everything in that ecosystem. And this has been done wrong many times, and it's also been done well. And so just kind of finding the sweet spots in between there. So blending different languages and concepts. And I really agonized over how to do this in Elixir, bringing in something that's very different, Haskell idioms in, down to naming, flow, and we'll go through all of this later too. So hopefully this can save you some time and some pain as well. There will be some code illustrations, but they'll all be fairly high level. I'm not going to go through code like in detail. So I might give, this is an example from a previous talk that I won't be using in this one, but we might have a geometric metaphor, and then that will get translated into some code that we can kind of walk through, but we won't go through every function in it, which I realize is a little bit of draw 2 circles, then finish the rest of the owl. All right, so let's dive in. Tool of thought. So thinking in general is about abstracting and forgetting details, right? We see a face as 2 dots in a line, but we still recognize it as a face. It's not any individual face, and we have developed this concept of face, but it's not every face on the planet, right? We have this general class of thing. Tools and methods are more important than our biology or the hardware in our computers. So we possibly use our minds less than our ancestors by some people's accounts. We don't have to remember, this berry under this kind of tree in this season means it's poisonous, right? We have Google. We have much better mental tools. So just as a few examples, metric is much easier to work with than imperial. Roman numerals were very hard to do arithmetic with, so we have Arabic numerals now. 24 hours and 360 degrees, they have nice divisors, instead of doing everything just in base 10. So sometimes it's good to change math. And these tools come in two flavors primarily. We have algorithms, which is the how, like long division, and abstraction, which is the what. So for example, a geometric metaphor. With Moore's law ending, we've actually, since the 1950s, we've had, in many domains, not all, in many, a larger speed up from improvements in algorithms than improvements in hardware, right? Obviously, we want both, but we're starting to hit a limit, unless the quantum computing people are to be believed. And yeah, so more beneficial to performance, and then obviously abstraction, for the human element, right? Code isn't just for communicating between humans and computers. It's also for between people, and having effective abstractions really helps with this. We've had a lot of recent success with this past couple of years. Machine learning obviously is slowly eating the world, and zero knowledge proofs, very, very cool, definitely worth checking out if you haven't seen them before. So when setting out to port something from one language into another, or a concept from one library into a totally different context, this is really the way that I look at it, right? And this isn't done for completeness. This is actually my process, at least. So we start with, at the very, very top, we have actual reality, something that's not directly knowable. Down below that, we have a philosophy. We turn into abstractions, concepts and practices, and to our grammar, vocabulary, our language, concrete code, a machine, or a VM, and then down into real world outcomes. And if we are taking something from context A and putting it into context B, really we are looking up this chain to something that is more abstract than what you're doing, and then re-implementing that in the new context, context B. So we're not just taking things directly and porting them over exactly letter for letter, word for word. We're going up to up something less concrete. There's some sweet spots here between generality and power, right? So things that are general have very, very low information. Few assumptions, many use cases. There's like the enum and enumerable in Elixir. Something with a lot more power is like a schema, right, for databases, Ecto. And in the middle, we have Gen Server, which hits this really nice sweet spot of, it does something specific, but it has enough use cases that you can do many, many things with it, and they're very, very powerful. So we've kind of hit this sweet spot for many applications. There's many kinds of libraries, obviously. So some for generality, like Witchcraft, or database adapters, frameworks, feature emulation like Typeclass, which we'll talk about a little bit later when we ported type classes over into Elixir, or some emulation of that because we don't have all the same features, right? Representation and interfaces, and patterns as well. So basic combinators or error handling, things like that. So the main meat of the talk is the principles for porting. Take these pieces of advice. Bit of motivation. I apologize to any Scala people in the room. This is the case that I tend to bring up a lot. There's two styles of Scala, right? Java without the braces and Haskell fanfiction. And the two don't really blend that well, right? And it's possible to do, but it's hard. Right, so you need a fairly experienced team to get those two to work together. You'll often hear, I'll need to convert my entire project for this library to make sense. It's great that you have lenses, but I would need to strip out everything and start from scratch, which obviously you want to avoid. I've seen this happen in lots of code bases. As a consultant, you walk in and somebody's gone and wrapped everything in futures, and they're flat mapping everything in Ruby, and it's supposed to be a Rails application, and the two hardcore functional programmers have left and nobody knows what's going on, right? So it becomes difficult when you're moving so far outside the norms of that language and in that case, Rails, framework, that it stops to make sense. So in an ideal world, we find a way to make this orthogonal to the way people are doing the rest of that. So it doesn't have to be quite that bad. So the three general categories, context independence, ethos, and completeness. These are the three that I gave during the New York talk last year. And I had a friend watching the video after in the summer. He was probably playing a little bit too much Breath of the Wild because he suggested, and it actually kind of fits, that these could be courage, wisdom, and power. Not bad, actually. So let's start with context independence, the courage to venture alone. Dijkstra has a quote for everything. So there has to be one in this talk too. Really, programming, and I agree here, programming is about mastering complexity. It's so easy to introduce complexity into our systems that our primary goal should be this. So each unit of code must be able to be taken on its own. An extension, so a concept being brought over from another language, should not alter or break any of the surrounding code or change its runtime semantics. Basically, orthogonality. So, clarity, composability, unambiguity. Basically the same class of thing as referential transparency, right? Making things clear in your code. Each chunk of code, so either horizontal or vertical, right, as it's laid out, should be able to be read on its own as it is, and you should be able to copy paste that somewhere else and have it still work. The most common place that this ends up getting broken is if you have some hidden state somewhere. So in Ethereum land, they just changed, you have to pay for compute. So every opcode has a fee associated with it. And they changed the price on one, or they were about to change the price on one. And that introduced a critical bug from something way off to the side, totally unrelated, right? That shouldn't happen, right? Everything should be totally independent from each other. This isn't about macros mangling your code. It's something very difficult to do in Elixir, thankfully, right? Because they've been all sanitized. It's possible, you have to try pretty hard. So as a simple case study, we'll look at algae. So this is bringing in algebraic data types into Elixir, which has structs, but they don't combine in any interesting way out of the box. So bootstrap those up into ADTs. Composition, orthogonality, and structured abstraction were all really great. Removed nothing, and everything still desugars down into the regular structs, into the regular system. But we added a structured DSL, types, and automatic default return values that can be overwritten, and constructor helpers. So you can call a .new to get one of these structs, just to save a bit of typing. And again, all of this desugars down into basic Elixir. So that looks a whole lot like this. This is an example with all the features, so I'm going to throw them all at you at once. But here we have def sum, some types, def data, so you have some type in a product. You have default values that we can add in, and each of these chunks can be taken separately. They don't have to be wrapped in the sum, right? It's totally orthogonal. This obviously represents a tree. Which then looks like this. After compilation, we get this .new, which then, if you were to type this out in regular Elixir, would be quite long. But this data structure is obviously very useful, right? Second principle, ethos, where we have to balance consistency, change, and restraint, especially restraint. Iverson, creator of APL, another good Canadian, basically saying that as your language becomes more useful, the more things that it can express, but less useful as you add more rules to it, right? So the fewer things you have to think about, the better, and the more expressivity you get, even better still. So you have to remain consistent with the character of the host language and the rules of it without completely forgetting about the features that you're trying to bring in, obviously, except where such consistency would conflict with the first principle. So, like all interesting things, this is the fuzziest of them because we're talking about the character of a language and its goals, right? So you have to understand the host language fairly well. But basically, we have our graph with the host, then we take our target, we go up, and then we synthesize down the middle like so. So exceptional pipes. In Elixir, we have just like F# this morning, we have this pipe operator, which is great. You end up with a lot of this flow metaphor. So we just extended that a little bit. Elixir has a finite number of operators. So these are two of them. Luckily, they point still. And so we can mix and match all of these. So in this case, the squiggly arrow says if I get an exception struct, so that's not a thrown exception, that's just the structure itself with the correct keys to say that it's an error, it will skip anything with a squiggly arrow on it so that we can collect them at the end. Kind of almost like an either. And then the last one, the 3 angle brackets, is if you encounter an error, throw it immediately. So just by using this flow metaphor, we can still maintain the character and get a totally different method of error handling. Tuples and exceptions are kind of an interesting one in Elixir. Early on, years ago, I guess I started these libraries about 5 years ago, exceptions were starting to become, or were obviously being designed as a richer set of data that you could pass around, right? Or throw and catch, et cetera. But Erlang uses tuples for everything, right? And they're running on the same VM. You want them to be interoperable. So they started moving back towards tuples. So it's interesting that Elixir's ethos is this richer, developer-centric view, but they've had to strip that out for compatibility. That being said, exceptional is the library that I get the most fan mail about, so it does say something. And the exception structs are antithetical to Erlang's ethos. So you end up with this kind of difficult thing where you have this shared system, right? We're abstracting over the VM now instead of the language. So if you have a system like this, the takeaway here is give them some way to get back to the original system, right? So everything here is still the same example as before, except now we can pipe into back to a tagged tuple, and we have an automatic way of getting back there, right? We lose some information, but we can. Some languages have a very strong character, and they're very opinionated, right? Rust, Haskell, right? Elm, Go. Erlang, not as much, right? It's designed for very practical purposes. We're running telecom switches. It's not ideologically motivated. It happens to end up in FP, but that wasn't the goal, right? Which is part of the reason why it doesn't feel so functional, right? When teaching, if I have anybody who is coming from, say, a Haskell background, they say, this doesn't feel like a functional language. It's like, well, it is, but, right? It doesn't go all in on all of the entire style. Elixir has this really nice property, though, of being so friendly and developer-focused that it's a little bit like tofu. You can flavor it with anything. So on that topic, what makes it so functional? So obviously FP, we're at a functional programming conference. We all like these things, right? Your code should be malleable. You should be able to change it and change the meaning of it as, your pure function can be thought of as a program, so you can now map from programs to programs, right? As opposed to just from functions to functions, which is something that you don't tend to think about a lot in Elixir because it is so operationally focused. We think about the machine and how, the sequence and the flow is going to happen. We don't think of it as transformations between things, right? So you can see, for example, a map as a cleaner way for a for loop. You're going to take each item, do something to it, and shove it back in a container at the end. Or you can see it as taking that past function, often an anonymous function, and transforming that into something that operates on, for example, a list. Right? So in this case, turning numbers into the word that represents that number, enum.map will then take your integers into lists of integers and strings into lists of strings, updating that anonymous function, which is a flipped way of thinking about things. And even when we were talking this morning in the keynote about point-free programming, if you're thinking about transformations between functions, you're more likely to be interested in point-free. Rather than just working on data and always doing application, you'll be thinking about composition. So it's when doing something like witchcraft, we're bringing in these idioms, we actually had to flip around quite a bit of logic to make that happen. There are some negative things in FP as well. The church chasm, if you have a hammer, everything looks like a nail, right? We'll just throw another combinator at it and it'll be fine. And we also have a tendency towards the darkest of magics, right? We'll just wrap it in an arrow and send it off, and we've just redefined function composition and everything will work. But very few people will have the background to understand that, and it's great if your team does, but it can be difficult. So this is a part of the community that we need to be more aware of. Again, I've just seen enough times where people have changed the entire system, written a library, and then wandered off without giving the appropriate training, documentation, etc. There are trade-offs, obviously. So people say, we have to have things that are very simple. Simplicity also has a cost. If you're simple in the small, you're complex in the large, and often vice versa. Now, obviously, you can be complex in both. So you should be striving for orthogonality, generality, and extensibility in every function. Actors are not safe from this. A lot of people talk about actors like they solve many problems, but not all of them. So each step is very simple, and you build up, people say it's like an organism, right? That's great, but organisms are very complex, right? They're hard to think about, hard to reason about. Sticking an abstraction on top of them is really nice. So GenStage, which is a consumer producer framework, really, really helps because it manages this, we're going from generality into power, right? We get, for those use cases, really nice language for talking about these things, right? So we're bringing in a new concept into the language. And complexity, when you're using small pieces that aren't orthogonal, it will grow faster than linear, right? You'll get more complexity than you have elements in your language. So when possible, provide a structured abstraction, which are things that we're all here probably quite familiar with, right? Especially anybody with, say, a Haskell or an ML background. So getting back to why Elixir doesn't feel very functional to a lot of people, this is the language spectrum that you're probably used to seeing, right? We have imperative to declarative, and we have our functional languages in the middle, but these languages don't really feel like each other, so that's kind of strange. This is another way of seeing it. So it's still organized basically left to right, but now we have a vertical dimension. And at the top, we have things that are mathematical or universal. On the left, operational, mechanistic, dynamic systems, right, like C. And on the right, linguistic, semiotic, contextual. Right? And the overall historical trend has been to move from left to right. Right? We're trying to get to something that people can understand well. Right? I've argued previously that one of the reasons why Elixir is so much more popular, has revitalized the Beam VM, is we've taken something, Erlang, which is up in this area, and then moved it down into something closer to something more human, basically. Also explains why it feels so different from Haskell, right? We have this distance here, right? It doesn't focus as much on the mathematics. We can also see this this spectrum as well as falling onto this chart, which makes it basically just bend over it as well, more or less. So when we're going up and looking at abstractions, I can often model them more easily depending on where they land in this spectrum as well. Pipes, I talked about this a little bit earlier. They break the ethos from Erlang, but they fit really well into Elixir, right? Clean, easy to follow, similar to OOs, like the dot syntax, right? Except flipped around so that the data is exposed. Helps it read like English, which is nice. The trade-offs is now you're forcing people into a mechanistic mode of thought, but it does clean up a lot of code, and you get, because you're doing composition, you do get this nice zoom effect. But it doesn't really apply to actors, which is what you're doing a lot of the time in Elixir anyway. So consider your metaphors, and if you have something that's very strong and very pervasive in the language, use it as much as possible. Guess language syntaxes. So, right, which language is this? Obviously it's Haskell, except no, it's not. This is Elixir. This is straight out of the docs for Witchcraft. We can take, so we don't have a type system, so we have to provide it this monad and the, which type we're in. But we can literally copy paste Haskell code in and it'll just work. Doesn't matter which language this is in. No, right? And the other question is this appropriate for Elixir? It's another question altogether. So using the chart again, we had to go up, but we also kind of borrowed syntax as well, because this is something strong enough from the guest language that didn't make sense without it, and it adds enough power that it makes sense. And finally, completeness, not the power of the dark side, the power of harmonious tools. Also another person with a quote for everything. So an extension must introduce or integrate its concept as completely as possible, right? As long as that doesn't conflict with the other two laws. Right, so synergistic combinators are ideal. This is APL, which is about 60 symbols or so that have a high level of orthogonality. So they're able to do things expressed in a very short sentence. The function itself will be shorter than naming it. So they don't name it, they just use the function, right? The 3 symbols that it is. A lot of APLers don't even use libraries because they just memorize the 6 symbols to do the thing, right? They're more than the sum of their parts, right? The more of these we have, or we've hit this sweet spot where at 60 of these things, we can do way more than 60 functions. We can combine them in all sorts of interesting ways because we used a good abstraction, which in this case is pretty much just linear algebra. It would be an absolute tragedy if we only had 10 of these, or 20, right? All 60 of them work together really nicely. Oh yes, and that one line of APL is Conway's Game of Life, which is running off to the side. So we can get a lot of power out of these simple, small sequences. Incompleteness drives me absolutely mad. The next time that I have somebody say like, oh yeah, I'm just going to port in maybe and bind or flat map, and that's it, that's my entire library. I mean, you could have so much more functionality by just adding a couple more functions to this, right? You're solving the immediate problem, but not the, as a library designer instead of an application designer, you need to be thinking ahead to all the different ways people could be using it, and the more utility you get, it could be exponential. So especially if we see functional programming as a modular system of transformations, we should have things like identity and constants, which we don't have in the standard lib in Elixir, which were introduced in other libraries. So let's take a look at Witchcraft a little bit. You can go pretty far if you have macros. We introduced something similar to type classes in a library called type class. We can update, clean, and power up kernel functions. We have curried, async, and flipped variants of a lot of things that are in the standard lib that you have to type out by hand otherwise. The sources on this are actually a little bit more interesting because we can go up to category theory and other forms of mathematics. We took the opportunity to clean up the class hierarchy. So Haskell's is a little bit, has some historical baggage in it. So we looked at PureScript, Fantasyland spec, a bunch of, Elm, etc. So in this case, it looked kind of more like this, right? With that last one being up to some math, and then synthesized down in the middle, witchcraft. So, but we still need to make it feel like Elixir, but also have these things work together. So we need to have them blend. So we need to have type class hierarchies, have lots of functions that work together nicely. So this is just one module, right? There's probably maybe 80 or 90 functions total in this library. Renaming these things for Elixir is hard because we also have to make them pipeable, right? So you really spend a lot of time agonizing over it. I'd say it's an anti-pattern to add bad puns like this, so don't do that. No matter how fun it is on a Friday night. Here is a list of operator aliases from Haskell into Elixir. Again, we don't have control over, we can't define any arbitrary combinator that we want or any arbitrary operator, sorry. So we had to stick with the ones that we had. We changed a lot of argument orders to make them pipeable, to make them reversible, and to make them work as you'd expect from the standard lib. And yes, everything's pipeable. We also had some nice advantages as well because Elixir is arity-based language. So we were able to clean up lift m and all the different numbers into a single named function, just lift, and then the number of arguments you give it changes how it behaves. Provide here is that operator spaceship. And then we had to give a flipped version as well, because it's kind of strange to pipe data into a function and then provide it more arguments after, right? Being able to flip it so that your function is going over all of these arguments makes a lot more sense. Type class. So we emulated type classes. We don't have types, for one. And what we really wanted was properties and a hierarchy, right? And to prove that we've had something already instead of just a protocol where it may or may not have, you don't know anything about the other protocols. So this fully desugars into modules and protocols. In fact, I think in a lot of ways it's cleaner. For example, to define something that is enumerable in Elixir, you give it a protocol, you define the protocol enumerable on it, and then you have to use the module enum and redefine those functions again in the second module. So this gives us both, which is nice. That's how it desugars. And gives us a completeness pattern, which is functions for free, right? If you have one or two functions that a bunch of others can depend on when you're implementing a protocol, then great, right? You do one thing and you get 20 functions for free, which is great. And keeping it sounding and feeling like Elixir, everything has a def on it. So this is a def class, extend, aware block. So that empty will end up, you have to define it, but it'll also get aliased into the main module. And then properties as well, because we do prop checks at compile time. So we're actually able to hijack the compilation process to do some prop testing in Forest, which I'll talk about a little bit later as well. And then def inst is defining an instance of this. And As a corollary, modularity is great. If you have some chunk that can be split off, please do. If for no other reason, then you can mark it as being more reusable. So key takeaways, specs more important than libraries, right? Or even more important than languages too. This is the actual concepts. Think about how language flows and any physical metaphors that they use, right? Our brains are really wired for physical, spatial metaphors. Naming is important, especially with directionality. I see a lot of people try to bring the pipe operator into Haskell. I say, please don't, because that's not how Haskell thinks. But if you do, that's fine. And you need to strike some balance between the two languages, or the two, the host environment and the concept that you're bringing in. So anti-patterns. Experience is the name everyone gives to their mistakes. So please learn from my mistakes. I have quite a few of them. So first off, if you feel like this, you've probably created a monster. Delete that code. Identify the way you fail, right? For me, it is enforcing correctness on people, right? Type class has that prop checker, and that actually dissuades people from using it, because compiling witchcraft takes forever, right? Just on the first time, but it still takes forever. This is a harder thing to do in libraries and application code. With the application, you tend to have a team, you're shipping a product, and you know that you have to be pragmatic. In a library, it's often often will start out as a personal project, and so you'll indulge every failure mode you have. Keep it simple. Don't use cute names for things. It's not a marketing exercise, right? If you call things truffle and ganache, etc., nobody will know what you're talking about. Call the things what they are. Yeah, so the type class property checking thing is my biggest regret from all of these libraries. I was inspired by this article by John DeGose, which is actually a good article about how we should have more principled type classes in Haskell and how we can clean up the Haskell type class system. It's slow. I wanted to encourage people to have good practices, but there's a difference between encouraging people and forcing it on them. Give users the choice. I really need to get back in there and generate test helpers instead. And then if people get it wrong, that's their fault, right? Obviously, don't overwrite the standard lib or kernel. In exceptional, right, where we're doing this exception handling and skipping over functions if we have a exception struct, I had people like filing issues and meeting me at conferences and asking, could you please just overwrite the pipe operator? I said, like, look, okay, fine, I'll give you the ability to do that, but there's a warning in here, please don't use it. This needs to be removed from this library because this isn't how you expect the pipe operator to work, right? It's confusing. Operators, super great. This applies to all languages, by the way. But if you're going to do this, make sure that you have a named version as well, so you can disambiguate, especially in languages where you can pipe. Elm has done a really nice job of this, reorganizing things so that you can just pipe in and then have a, an and then, for example. In Elixir, I have a library called operator that lets you define an operator on a named function. So the operator is the alias instead. But again, we have a limited number of these in Elixir. It's like 16 or something. So give them the option, right? What does this do? I have this operator in 2 libraries. And if a user is using both of them, they need to use the named functions to make it clear. Right, so we have functor.lift and exception or continue, which are both squiggly arrow. So let's take all of this and put it all together. Let's port a thing. Just with a toy example, something that you shouldn't do at home. So what to port? Well, I mean, I've already gone starting on this way. So let's go this way. People say that Elixir is a better Ruby. It's not, but let's make Elixir into a better Ruby. So features, right? A bunch of them. We're not going to do inheritance because so entirely possible. It's just a lot more code. I was hoping to have a fully working version of this, and it's like partway done, but I have the desugared code at least available. So it turns out that this is both totally possible and a terrible idea. So please don't do this. And a better Ruby is a Garnet, so we'll call this Garnet. So the full version, right? Data hiding, all functionality behind a single interface, instant variables persist between calls. We're not going to do inheritance, but I've done things similar to that in the past. So what does this look like? This is maybe too close to Ruby, and we're breaking just off the bat a whole bunch of Elixir conventions, right? You should have def class, for example. We're using the 3 squigglies because the @ symbol is taken by the compile step with modules. So clean those up really quickly. Now we have def everything, which is great. We have def class, we have accessors, we have getters, static methods, constructors, regular methods. We can rewrite this with the equals to be a setter, and then detect when it doesn't have it to be a getter. We can return ourself, and then, yeah, there's a getter as well. And a little helper library called garnet.object, and we're going to shove everything into an agent. And just for simplicity, for right now, we could do this with a struct, with macros, but just, you know, for a first pass, we'll do this with a map as the state. And what this really ends up looking like, desugaring is into a whole bunch of Elixir code, obviously. And it totally works, right? It works as you would expect. You can call, you have this struct that you pass around. You can call methods on it. It'll update a local state, and you keep returning back that same struct, right? So we have a few features here. Hopefully it's not too small to read. But we have this build so that we can create this struct and pass it in recursively. Our static method can just be a regular function, right? These chunks of code, that's the struct, and then the definition of it being passed in with the process ID. These are our methods. And we have to wrap everything in anonymous functions so that the compiler doesn't complain, basically. So that's too far, right? Revert, this is not Elixir anymore. Right, the getter setter sugar is fine. We don't have any control over start or start link. Static methods are just regular functions. Data hiding can be put in a process, etc. Right? And we should be able to pipe things. We should be able to pipe straight down. So V2 is much smaller and cleaned up. We're no longer doing this dot syntax. We will just pipe things through and pass the PID around. We still have constructors and methods. Statics are now just regular def, and we're just going to use the module as regular. And this is a very common pattern anyway, and this is actually something now that's useful. Just wrap it in an interface. Right? No longer structure builder, no more anonymous functions, much simpler to implement. So some final takeaways. Standard lib's not sacred. Your language isn't sacred. You think of these libraries as a language extension. Languages are more than their keywords. They matter less than concepts, and focus on cohesion more than other things. And love your code, right? Because code should be like play. Thank you.